Okay, I don't know why I procrastinated recording this so long, but here is my EER diagram. At kind of the center of everything is the room table and the building table, which are linked. Every room knows what building it belongs to as a foreign key. One building can have many rooms. Room can only belong to one building. Um, Off of that, we have three different points of interest: printers, microwaves, and vending machines. They all know optionally what room they belong to. Most of them in practice did not end up being bound to rooms, and room got not as much use as I hoped. And then they know for sure what building they're in, and then they have to have a description of where they are. And then most of them in practice also have coordinates. We have a department can have its headquarters in a room. Um, and then different departments can run different meetings. So, for example, like the computing drop-in lab or the data science tutoring thing, and then every meeting can meet at different times. And this table in particular, these two really did not. Um, I didn't really know where to get good data on it, so these are pretty empty. But we can show that now by going over to here and showing the data. So buildings, this should be exhaustive. So a big problem throughout this is just that I also used this database in a group project, and eventually I dropped parity between the MySQL database and the JavaScript version of it, the JSON object. Um, so it a lot of the stuff added towards the end didn't make it in, but I think this is exhaustive. We have the departments, which I don't think I have all of them, but there is a lot, and I'm if you see one where, for example, English and philosophy, that is a one of the colleges that has departments, and you can see that because sorry, I'm looking at the wrong. Uh, I meant to say. Okay, language and letters is what I meant to be looking at. When the department ID and the college ID are the same, that's like saying it's its own boss, or in other words, this is a college and not a department. And because I just didn't want to split that out into its own table, since it wouldn't really have any other unique data. Um, and that way, a meeting can belong to either a department or a college. That being said, this literally only has the STC, the tutoring lab, and then the meet times for that. So the idea being that you would be able to filter on meetings for like which meetings, what are all the places that are meeting on Tuesday at 3:30. On Tuesdays at 3:30, I should say. Okay, we have the microwave table. This definitely does not have all the data that the JSON version has, unfortunately. We have printers. This used to be split into printer and copier until that just didn't get documented. And then the rooms, which also they know what floor they're on. Vending machines, I don't think that's a complete list. That's old data, but it's, not wrong. Vending machine has item, which even encodes the slot. So in theory, you could use this to make a visualization of a vending machine and like show where all the items are. And then the actual items, which is the name and the price. And I believe I set this up so that you can have the same name with different prices in case two different vending machines sell the same thing for different prices. You just do that internally as two different items. Okay, so my example queries, starting off simple with an example of a function. We are taking the average of the prices from the item table and rounding that to 2 decimal places. So we're getting in dollars and cents. What is the average price of something in one of the vending machines? I do wish that data were more complete because then we would, it would be a little more real. But it's at least the average of the items in one or two of the vending machines. You have a join here. Very useful. This lets you see what building a microwave is in did this kind of thing a lot. The building table basically exists just to get joined to whatever needs it in like most of my select statements. We also showed the coordinates of the microwave. And if the STC had more than one microwave in it, this would list all of them. But that is not the case. Not very many buildings, if any, have more than one microwave in the same building. For a case statement, I decided to go all out and do two cases here. We have a list of the buildings, and then this is, are they further north or south, and are they further west or east of the average latitude and of the average longitude? So we can see the Austin building is southwest, and that makes sense. Benson is southwest. I'm actually surprised that's not east, but Clark is northeast. That makes sense, and you get the idea. For an outer join, we give a list of all of the buildings, and if they include microwaves, we show those microwaves. Unfortunately, none of the buildings have two microwaves. If it did, you would see multiple rows for any buildings that had multiple microwaves. Group by, I got a big fancy one here. I will not be explaining the entirety of this query, but just notice this union here and here, and that this is basically the same query repeated 3 times. Once for printers, once for microwaves, and once for vending machines. So we union all that into just a big long list of all the points of interest, and then we're going to group by building, and we count how many records are matched for each building, and we call that points of interest. So we see the Clark building has 10 points of interest in it, all the way down to the STC only has 1, which that should really be more like 5 or 6, but again, that's outdated, sadly. For a subquery, we say our subquery is going to be find the highest floor of any room in the room table, and then we're going to find all the rooms and what building they're in, using this join here, all the rooms that are on that floor. So as it turns out, the highest room on campus that's documented is in the Smith building. Room 450 in the Smith building is on the 4th floor, and I have not logged anything higher or even as high. And then for a window function, we have this, which counts the room names across partitioning by building ID and floor, and so we get the number of rooms on a floor, and then we can see for each room how many other rooms is it sharing that floor with. We can see the most that I have written down on one floor is the 2nd floor of the Rex building, and that's about it. Okay, what was the show the queries, and I guess that's just time for Streamlit then. So here's the Streamlit thing. So if I say STC run query, it tells me there is a microwave in the STC. It tells me, describes where it is, and it gives me its coordinates. If I do the same thing, I think the Benson should have one. Yeah, that one doesn't have that data entered, but you get the idea. So we can describe a new microwave. You can see somehow it's just automatically remembered this, and this is what I use to make it easy to find so I can delete it later, because I'm using real data. I don't want to be putting in fake data. And we can put that in the Clark, and we can say it has a latitude. We'll say it's 50 degrees north. It's actually a degree into Canada, I guess, and a latitude of, longitude, and we'll use a realistic longitude there. I think that's pretty close to our actual coordinates. And insert, and oh, it refreshed all by itself. So that's weird. Didn't do that before. So yeah, I think that's it.